folks, welcome back to our video of the area of regular polygons. This is video number 2. I'll see how far I can get with this, but if you haven't seen the previous video about angle measures and the notes and vocabulary, please don't watch this one yet. It could get confusing. But a quick recap of what we've already discussed. These were the notes from the previous video. We learned about the apothem, we learned about radii, and we learned about angle measures that happen in regular polygons. So with that information, what we can now do is start to find the area of stuff. Okay, so let's take a look at some notes now for area. There's going to be some important notes here because it gets into the actual new material. Now, the first thing we should know that if two figures are congruent, then their areas are equal. That should be helpful when we talk about triangles. But let's talk about the area of a regular polygon. Now, the important thing to note is that this is for a regular polygon. So please remember what regular means. All the sides are congruent. Okay, so what is the area of a regular polygon? The area of a regular polygon is half the product of the apothem and the perimeter. So you have to remember what perimeter is and how we find it. Perimeter, as you can see from this very helpful diagram, if you can't tell what perimeter is from this diagram, something's wrong. Perimeter is the way around the addition of all the lengths. That's the perimeter. So when we add up all the sides of our regular polygon, we get a perimeter. Okay, so how do we find a perimeter? Add all sides. Okay. So that is how we find the area of a regular polygon. And another background check on vocabulary. In any regular polygon, we have a center that goes out to a circumscribed circle. So we have a center, and from the center to a vertex is the radius, and from the center to a side is the apothem. Okay, so we have to know all that different vocab, and again, we talked about that in the previous video. Now, there's another way we can talk about area of regular polygons. We can use triangles. Now, when we talk about triangles, we have to remember a few things. We can talk about right triangles that come back to using the Pythagorean theorem. Okay, so we have the sum of the squares of the legs is equal to the square of the hypotenuse. And we also have a quick shortcut with the Pythagorean triple, the 3, 4, 5. I mean, or any Pythagorean triple if you know them. But we got to remember, if we're talking about using triangles to come up with area, what is cool about right triangles? Aside from the Pythagorean theorem, we also have special right triangles. Okay, so special right triangles are 30, 60, 90 triangle, where the short leg is half the hypotenuse, and the long leg is the short leg times the square root of 3. And the 45, 45, 90 right triangle, where our legs are congruent and the hypotenuse is the leg times the square root of 2. So we have our special right triangles to recall, and we also have trigonometry to recall. Okay, so remember good old Chief SOHCAHTOA, where in given any right triangle, if you have an angle measure, you can find the sine of the angle by looking at the opposite side over the hypotenuse, or the sine of x being a over c. You have the cosine of the angle, which is the adjacent leg over the hypotenuse, or the cosine of x being b over c, and the tangent of the angle being the opposite over the adjacent, or a over b. Okay, so all of this stuff comes back into play from what we had learned in Chapter 8 when we're talking about area of a regular polygon. So all of that is about to be used. Hang on tight, buckle up, and let's do some math. Now, we're looking at the area of a regular polygon. In this example, we give, well, clearly a regular decagon, because it says so. It's regular, so all the sides are the same. And we're going to find the area of this. Now, a couple things to recall. First of all, what is the area of any regular polygon? It's 1/2 the apothem times the perimeter. Okay, so we're looking at area being 1/2 the apothem times the perimeter. Now, the cool thing is that we are given the apothem. So in this diagram, we have the apothem. It's 12.3 inches. Okay, so we have our apothem in the diagram. What we don't have is the perimeter. How are we going to find the perimeter here? We have a decagon, and decagon means 10 sides. Okay, we have 10 sides, so you can count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 sides. Each side is 8 inches, so the perimeter of the decagon is going to be 8 inches times 10, or 80 inches. So we have our perimeter of 80 and our apothem of 12.3. So our area is going to be 1/2 times 12.3 times 80. Okay, so that's how we find the perimeter of this regular decagon. The rest is calculator work. Okay, so we can just calculate 12.3 times 80 and divide by 2. Or we can just do 80 divided by 2 in our head and call it 40 times 12.3. And we get 492 square inches. Okay, so we're going to end up with 492 square inches. And that is the area of our regular decagon. Okay, so that's how the area formula works. We have our apothem and our perimeter. So let's do another example. What's the area of a regular pentagon now with an 8 centimeter apothem and 12.6 centimeter sides? So we don't need a picture for this, but if you want to, go ahead and draw one. We have a pentagon. Remember how to draw a pentagon? Right? But it's going to be regular, so keep in mind this is regular. Clearly my picture is not regular. But we know we have the area of that regular polygon is going to be 1/2 the apothem times the perimeter. The apothem is given to us as 8 centimeters. So we have 1/2 times 8. And the perimeter needs to be found with our 11.6 centimeter side. So remember what perimeter is. We're going to add up all the sides. There are 5 sides, okay, because we have a pentagon. There are 5 sides, and each side is 11.6 centimeters. So some quick calculator work, 11.6 times 5. So we have 58 is our perimeter, 58 centimeters is our perimeter. So back to the area formula. It's 1/2 the apothem times the perimeter, which we just found is 58. Okay, so the rest, again, calculator work, or if you want to do some stuff in your head, 1/2 of 8 is 4, so 4 times 58. Either way, you're going to get up with 232 square centimeters. Okay, so 200... How'd you like that 3? 232 square centimeters. So that's how we find the area. Okay, so that's the area in general. Let's get crazy, shall we? I'm going to push this video a little bit. Or maybe I should stop. I'm going to stop here. We'll call this a video a day, video 2, just in general the area of a regular polygon. We'll come back with a 3rd video with using trig, and then we'll see how that works. Okay? Okay, so see you guys in a little bit.